Hi, it's Aaron from Archaea here. In this video I'm going to show you how to calibrate your Loki Synth module. I'm going to go through all the steps in the assembly instructions to do a complete calibration. See the link in the description below to the written instructions. To do this calibration you're going to need three basic tools: a multimeter, a small flathead screwdriver, and something to measure frequency, such as an instrument tuner or a tuning app on a phone. I'm going to be using this trimmer tool, which is basically a screwdriver too, but it's easier for me to show this on the video. To calibrate the Loki, we're going to be hooking the multimeter up to the test points, and then we're going to be adjusting the trimmers with a screwdriver. When you are adjusting the trimmers, it's useful to hold Loki still on the table. So you can do this by putting some putty tack on the back, or some masking tape. I'm going to put it in this block of wood to hold it steady. Okay, let's get started. The first step is to calibrate the reference voltage. So before we do any calibration, you need to get the panels set up, all the controls in this configuration. This is also shown in the written instructions. So we're going to power on the Loki and set the multimeter to DC voltage. And then we're going to take two clips. The black clip is going to go on the ground connection, which is this second one here, and the red on the reference voltage. Okay, and we're getting a reading of about 3.1 volts, so we want to get to 3 1/3. Now the trimmer for this is actually on the right. Okay, so clockwise increases the value, so I'm going to turn it clockwise until we get to 3 1/3. If your meter doesn't have 3 decimal places, that's fine. It's a reference, so it just needs to be about 3.3. Okay. To calibrate the glide slope, you'll also need a CV source. So I'm going to connect up my keyboard, which outputs control voltage, to the frequency input here on VCO1. And then I'm going to connect the red clip to the freak point here, which is second from the top on the left. And we can see on the meter here that we're reading at 7.965. So my keyboard outputs or is calibrated to just under 8 volts. This is fine. We're only interested in the relative voltages. So the idea is to measure the voltage that we're getting on the glide output. And we can see that we're getting 8.1 on that, and we need to trim that down to as close as we can to the incoming voltage. So to do this, we adjust trimmer number 1, and I'm going to go anti-clockwise. Just turn it slowly to get to 7.965. Again, get as close as you can. Okay. For the envelope offset, I'm going to connect to the AR trim point, which is on the top right. You can leave the black or the ground connection where it is. So we're also going to need a gate signal. So I'm going to use a gate coming from my keyboard and connect it up to the gate input here of VCO1. So when I play a note now, we can see that the gate is coming on the Loki, and the voltage is rising up to just over 5 volts. Now, if you're getting this, then it doesn't really need any adjustment. Sometimes this voltage can be a bit lower. We could have a slightly faster rise to 5 volts. I'm going to turn that up a bit. So for this, we adjust trimmer number 13. So I'm going to turn that clockwise. Just give it a couple of turns. That looks good to me. The voltage climbs up rapidly to begin with to around 5 volts, and then it will slowly increase, and that's normal. That's what you'd expect. You just trim that off so that to make sure it gets to 5 volts. So there's a couple of ways in which we can calibrate the pulse width modulation centering. You can either, if your meter has a duty cycle or a pulse width measuring function, you can use that directly, or you can just listen to the output of the oscillator and get a pretty good sense of when it's centered. And so, in other words, producing a square wave. So the first thing you want to check is that the PWM control is centered, and you'll feel a slight click on the control when you've got that centered. So I'm going to show you how to do it with the meter. You can connect up to the pulse output, PUL, on the trim point here. Set your control voltage to 2.75 volts or an A2 note. Okay. And then set your meter up to measure duty cycle. So we can see it's at 89%. I'm going to actually turn up the sound of the oscillator. So first of all, let's get that sound. I'm going to plug into the square wave out, or pulse out. Okay, let's bring that up. Okay, so there's the oscillator, and that's obviously not square sounding. It's at nearly 90%. So we're going to turn trimmer number 7. And you can hear that getting more square sounding as I turn anti-clockwise to lower it. And we're aiming for 50%. Okay, that's pretty close. I think that's close enough, and you can hear that sounds like a square wave now, rather than having any kind of buzzy sounds of a pulse wave. For the VCA offset calibration, you want to put 5 volts into the frequency input of VCO1, which is showing here just under 5 volts for my keyboard, from a C5 note. So take the red probe from the multimeter and then put it onto the output, which is the lower right trim point. If you keep the multimeter on DC measurement, now we're going to switch on the envelope into continuous mode. So that's the top position like that. And so we're getting an offset there of -6 volts. So we're going to adjust trimmer number 16 to try and get that to as close to 0 volts as we can. So I'm turning clockwise to increase the voltage. It's hard to get it dead on, but it's not too critical. You just want to get it as close as possible. And that's probably good. One thing to note is you need to make sure that you have the pulse width set to the center. For VCA closed calibration, you first need to set the envelope to window or the middle position, and then turn the frequency of VCO2 up to about 12 o'clock, which is roughly 10 times a second, and also increase AM2 to maximum. I'm then going to take audio out of the main output, and then we're going to turn trimmer number 17 up to the maximum, so turn it clockwise, roughly about 10 times. Okay, so I'm going to bring up the audio on Loki now. And you can hear that clicking. Now the idea is to turn trimmer number 17 until that clicking just goes away. And the clicking is caused by the effect of VCO2 on the envelope, so we're setting it to the kind of 0 position. Yeah, I'd say that's good. We're going to calibrate the oscillators next. This is the most complex part of calibration, and so it's important to work through the steps slowly and make small adjustments. That way you don't overshoot and have to bring things back in. So we're aiming to calibrate 3 things: the bass tuning, the octave tracking for each volt in the control voltage, and then the high frequency tracking. The difficult part of this process is that when any tracking is adjusted, it will also affect the bass tuning. But we'll see how to compensate for this as we go along. So the measurement setup I have is to connect frequency meter to the pulse output. I've got the control voltage coming in, and I also find it handy to measure the frequency voltage so that I can just double check which octave I'm trying to tune against. So the first step is to reset the bass tuning and the tracking. So we can first of all reset the tracking with trimmer 6. And you want to turn it counterclockwise about 10 turns until it's zeroed. Okay, so now I'm going to try and set the bass tuning up for an initial calibration. So we have got 2.7 volts. This is what my keyboard is outputting. This is meant to represent 2.75 or an A2 note, which should be 110 Hertz. So I normally tune on the A notes because it makes the math simpler: 110, 220, 440, and so on. So what we're aiming to do is, for each voltage increase of 1 volt, we want to double the frequency. So each voltage represents an octave. Okay, so to get the bass tuning to 110, so it's showing here currently at just over 90. So I'm going to turn trimmer number 3. And turn it clockwise up to 110. You don't have to be too accurate on this first step because we're going to be recalibrating this bass frequency as we go along. So now what we're interested in is when we can go up a volt to, say, 3.7, which you can see there, we want to get the frequency coming out at 220. So you can see it's coming at 222, so we want to lower the volts per octave. And we do that using trimmer 2. So I'm going to turn it counterclockwise. You'll see that it's actually increasing the frequency. Because again, it's going to offset the bass frequency. So if I come back down to 110, you can see that has slightly increased. So to compensate for that bass frequency change, I'm just going to use the tuning on the front panel, just bring it back down to 110 again, and go back up to 3.7 volts. Okay, so we've come down to 221 now. It can be really helpful to, if you can set up your control voltage somewhere easily so that you can switch between octaves. I can do that here quickly. You don't need to do that, you can just use a normal keyboard, just makes it easier. Okay, so I'm going to bring that down a bit more, the volts per octave, so that's trimmer 2 again, I'm going to bring it down. And then come back down to 110. Maybe just reduce slightly the bass frequency using the tune dial again and take a look. Okay, so we need to go more because we're aiming for 220. I'm going to give that a couple of twists. It's gone back to 222. So let's bring the tuning back down again. They're just around 110. I mean, one thing you'll notice is that the oscillators, because they're analog, they will drift around a bit. Part of like what I think is nice about their sound, they're not always dead on. Okay, and we're much closer to 220 now. I'm going to just trim off a little bit. It's about 0.3, 0.4 above 220. Maybe just a bit more. Okay, so yeah, that's moved up again, so I'm going to just bring that down. Okay, I'd say that's pretty close now. So the next step is to do the high track, and we want to go up to, so we have 2.75 in effect, what should be. If we come up to 6.75, what we're aiming for here is 1760 Hertz. So you see it's a bit flat, so that's where the high frequency tracking comes in. We want to add another like 9 Hertz. So I'm going to go to trim 6. I'm going to turn it clockwise. Okay, so we've come up to 1760, but again, that will change the bass, so we need to double check our bass tuning back down at 110. And it does look like it's a bit sharp now if I go through the octaves. So if we bring that down, you can see that we've got to add more tracking. I'm going to turn it clockwise again. And again, it's slightly sharp, but it's almost there. So let's come down. Again, turn up 6. Okay, let's see where we are. Say a little bit more. Just going to do a tiny bit more. And I'd say that's pretty spot on, so let's have a listen. Okay, that sounds pretty good. The next step is to calibrate the different octave ranges of VCO1. So when I flick the octave switch, when we're on an A2 note, we should get 110, 220, 440. So we need to trim these out. So the 220 is trimmer number 4. We need to bring that down. Let's turn it counterclockwise until you get to 220. And the same for 440, which is trimmer number 5. So again, just really small twists. And that should be pretty spot on. Let's have a listen to that. Okay, that sounds good. And finally, we need to reset the bass tuning again. So I'm going to turn up the tune to the center on the front panel. And then I want to bring down the bass frequency to 110 again. So that's trimmer number 3, counterclockwise. We check the octaves, then just trim that up slightly. And there we go. And that completes VCO1. Now we're going to calibrate VCO2. So it's going to be similar to VCO1, but this time we have this setup where I've taken the glide out, put it into the frequency in of VCO2, and I'm taking the out directly out of VCO2, which is what we're going to measure the frequency of. You need to make sure that your tuning is centered, your frequency is at 0, that your range is on note. Start with the triangle wave and turn the sync off. So the first step, as before, is to zero the high tracking. So we do that with 2 trimmers this time, so 10 and 12. We're going to turn them counterclockwise about 10 revolutions again. And number 12. Okay, so again, we're putting in an A2 or 2.75 volts, and we're getting frequency there of 116. So we're going to set the base frequency now just to a starting point. So I'm going to bring it down to 110. And then if I go up an octave, I can see, well, luckily this is already pretty spot on. It's slightly too high, so we're going to bring it down a bit. So we do that. The octave per volt trimmer this time is number 11. So I'm going to turn it again counterclockwise a bit. Go back down to 110. Reset using the front panel. Okay, let's come up. And we're pretty much there. So let's go with that. And we can see as we go up the octaves, it is a bit flat again. So we need to increase the high tracking. So the high tracking for the triangle wave is trimmer number 12. So I'm going to turn that up. Let's aim for 1760 again. And again, we'll need to trim down. Using the front panel, just get the frequency down again and see where we are. Go back up to 6.75 volts. Okay, so we're at 10 hertz again. I'm going to repeat this now. So trimmer number 12 again. Okay, nearly there. Okay, I'd say that's spot on. Let's have a listen to that. Okay, now we need to do the same thing for the sawtooth wave, so switch that over. And that's showing its base frequency at 260, so we're going to bring that down with trimmer 9. This will take quite a few turns to get this down to 110. Okay, so they're both now at 110. Now the two waves follow the same volt per octave tracking, so what we're interested in is when we get up to the high frequencies, again getting the tracking right there. So this time it's trimmer number 10. Let's have a look at the base frequency. So that has gone up again. This time I'm going to lower the base frequency using the trimmer rather than the front panel. So we're about a hertz up. We want to go down, and that is trimmer number 9 again. Because if we change the front panel, we'll also change the tuning of the triangle wave. And again, we need a bit more tracking. So let's turn 10 up again. Go back down to 110 hertz. So we need to bring that down a bit more with trimmer number 9. Let's keep repeating that until we get close. Say one more time. Okay, I'd say that looks good. So let's hear that. Okay, so they're both in tune, and then the final step is to do the final bass calibration. So let's bring the tuning back up to the center. Okay, and now they're both, by adjusting just trimmer number 8, they're both now at 110. Okay, so that's it for VCO2. The final step is to calibrate the volt per octave for the filter. So in this setup, I've now put the glide into the CM2 input to the filter. I've turned the attenuator right up, put the resonance up, set the cutoff to about 9 o'clock, and switch VCO1 input off, resonance to minus, and make sure that AM1 is set to max. I've also switched the envelope on to continuous, and I'm measuring the frequency at the main output. So it's a similar sort of process to the oscillators. So we're seeing that we're getting 172 for the A2 note at 2.75 volts. So the first thing to do is to get that bass tuning right. This time we're going to be using trimmer 14. So I'm going to bring that down to 110. Okay, and now let's go up an octave. We can see it needs to be brought down. So I'm going to, this time we're going to actually track between 110 and 440. The filter isn't as accurate as the oscillators. It doesn't have high frequency tracking. So it's usable over a few octaves, and we're actually going to calibrate to 440 this time. So I'm going to bring down the tracking, which is trimmer 15. Now what we can see is it's not moving there, but instead the 110, the A2 note, is actually getting sharper. So I'm going to keep turning that a bit, and then we'll reset the bass and see where we are. Okay, so let's come down with 14. So let's get it to 110 again. Okay, we've gone a bit far, so I'm going to increase and reset the bass. Okay, that looks pretty good. We can see that the A3 is a bit sharp. This is the kind of natural curve of the filter, which is about as close as we're going to get it. So let's have a listen. What we've got it set up here. With the resonance at maximum, it's a sine wave oscillator. And that's the expected response of the filter. So I can play a sequence through it, and we can hear that that's a sine oscillator. And that's it. That completes the calibration.